Okay, so we start now the next session. The next session is chaired by Alessandro Saffiotti from Örebro University. Alessandro is the scientific coordinator of AI4EU and is also the work package leader of WP7, that is the one related to the research activity. Alessandro, I will leave you the floor for introducing the speakers. Thank you so much.
So good morning, everybody. Welcome, everybody. And thanks a lot for AI4EU and to all the people in Bologna for organizing this event. As Michela said, I am actually the scientific coordinator and leader of the research work package in AI4EU. But you remember what Joachim said this morning very nicely, is that everybody in the project realized at some point the need to contribute to the development of the platform. So WP7, the research work package, actually smoothly went from being mainly creators and contributors of AI asset and AI content to actually being people who contributed also to create the tools where this AI content could be published. So a lot of people in WP7 started to work also on helping to create and to improve the platform, as did the other people here. And the goal of this session is really to give you a hint of how you can keep on this work. So use the platform now. Now the platform is in the hands, will be in the hands of the community. So this session is really meant to give you an idea of how the platform is built, how you can contribute to that, you can use it to put your content and even use it to further develop the platform, so it really becomes our community platform. Ioannis Molas, Martin Wells, Peter Schuller will actually help me in this task this morning. And let me just tell you a little bit what we are going to show you this morning. So you've seen already from Joachim's presentation and from all yesterday day that the main platform today is consisting of these main two parts, actually. The web portal or Drupal-based content management system that contain all the different assets from the platform, and asset in a very general way. So it includes organization profiles, it includes education material, it includes software, data sets, news, and so on. And one specific service, and there are more and more to come, but one specific important service, which is this AI for experiment or testing and experimentation service. You have also seen from the presentation that AI4EU basically went from a centralized development model to a distributed development model, more or less halfway. And that's really a key to what I want to tell you before, because now that the platform has been developed by a community of people, we are in a good position to keep using and developing further the platform in the future in a community way. So you've seen already this timeline yesterday also and today. So the technical board, which has been coordinating the distributed development of the platform in the last 18 months, will still continue the work, will still coordinate the development of the platform for all people from AI4EU, from the other ICT48, ICT49 project, and from any other project in the future. So for this to happen, I want to give you a feeling of how you can actually join, how you can use, and also you can contribute to the platform. So that's what we're going to see today. We're going to see basically three things. We'll see how you can publish your content. So this is what most of the users will want to do. You have papers, you have data sets, you have software, you have your organization profile, and you want to publish it on the platform. There will be, there is an editorial team actually, which will be open actually, that will review this content. So we guarantee that there is some sort of consistency in quality and in format of presentation. this is what most of you will do. Some of you may actually do more. Some of you may find that maybe the current way the platform is structured is not sufficient for you. Maybe you want to publish some type of content for which there is not a good place yet. There is not a good content type yet, or maybe you want to modify it. Or maybe you want to create a new service to add to the platform. There is a team, for instance, which is working on a very nice chatbot to add as a service to the platform. Then you can do that. Contributions will be open, will be reviewed by a technical board to make sure that there is coherence. And we'll tell you a little bit how you can do that type of things. And the third thing we want to tell you today is how you actually can contribute to the other part of the platform, this AI experiment, testing and experimentation facility, how you can put your asset in the experiment marketplace, how you can combine your asset into full AI system, try different ways, deploy them, run it, and so on. So these people will help me to do that. We'll start by the first part about publishing your content. I will actually give you a guided tour on the platform about how to do that. Then I will leave the floor to Ioannis, who will tell you how you can actually contribute to further develop the CMS system with new functionalities, new content type, new taxonomies, new services, whatever. And finally, we'll leave the floor to Martin and to Peter, who will talk extensively on the AI experiment, how you can actually use and contribute to the AI experiment part of the platform. Okay, so first part, how you can publish your content. Yeah. So what type of content you can publish? Well, if you've gone to the platform, and I'm sure all of you have done it already, you've seen that the main type of content you can publish are AI assets, and as I said, these include software, data set, libraries, AI services also, and so on. Can be news and event, can be education material like courses, training, tutorials, and so on. Can be description of pilots. There are case studies. You can publish about funding opportunities. We have a few. You can publish about your own organization, actually, and about projects, small, large, national, international projects also. And what we're going to see in a moment in a demo is a simple case where I will show you how to publish three of these things. One an AI asset, a tutorial, and a small project that is the one in which both asset and tutorial have been created, that will put them together and make sure that people can access together. I will go through a scenario, a user scenario, where I imagine that there is a researcher, Alex, at Örebro University. This researcher has developed a great answer set programming-based planner for a robotic swarm. It's not true. I never did that, but suppose I did it. Suppose I also created a tutorial that explains how to use this planner. And also suppose that I did that, of course, with other people and maybe in cooperation with other partners from the University of Bologna, for instance, in a small project. It may be one of the micro projects that Paul was just telling you about. It can be any other sort of small project. Now what we want to do, suppose, is to publish all this stuff on the platform, possibly together, so it is also visible that they belong to the same project, that they are output of the same project and activity. Okay, so you may now see my my browser. So here is what you see when you get to the when you enter into the platform. You can do a lot when you enter into the platform, even if you don't log in. You can actually go around, search, browse the AI catalog, and so on. If you want to contribute to new stuff, however, you need to log in into the platform. To log in into the platform, you go up here, and you basically log in with your ECAS so the European system login, the same one that you use to log in to your European, to manage your European projects, for instance. If you don't know how to do that, or if you don't have an account on ECAS, just go here and you will be sent to the European site when you can create a new account or just log in with your existing account. So I will log in with my ECAS account here. Okay, now I am in the platform, logged in using my ECAS account. Now on the platform, I can actually see here what are, so the dashboard, what are actually the current assets which I have already published, which may be already published or may be in review if they're still not being approved for publication. Now the first thing I want to do, I want to actually put on my my great asset about planning for a swarm robot system. Maybe the first thing I want to do is to go to the catalog to familiarize with the other asset and familiarize with the way the assets have been described. So I try to describe my asset in a similar way. Here is the catalog, as you see, is divided into the four research areas that we used in AI4EU to identify human-centered AI, collaborative AI, explainable AI, integrative AI. In fact, if you go to the research page, you get an explanation of these 5 research areas. And then in the catalog, as I said, you can have different type of assets like dataset, Docker container, executable, Jupyter notebook, library, machine learning model, or a tutorial. You can have different technical categories, business category, or you can put keywords as you want. So I said my asset is using answer set programming. So let's see if there is already something in the catalog which uses answer set programming. Yes, there are a few things. Let's take a random one of these, X-Lite. So I get a feeling of how other people establish their asset and try to do something similar. So here is the X-Lite asset, sorry, this is a Docker container in this case. There is a link to where the asset is actually stored, and here is a description. Short main characteristic, more detailed description where I can put all sorts of detail about how to run the asset, maybe additional information, papers, and so on. And then labels about research areas, about the technical categories, a set of free keywords, and so on. Okay, so I get an idea of how an asset might look like. So I go back to my personal space, and now I can submit my asset. So I do a submit new content, and I'm in this contribution gateway where I can actually select the type of content I want to submit. It can be my own organization, actually, if it is not already there, case study, and other things, and an AI asset, which is what I'm going to select now. Okay. And now is a form where I can actually say, okay, this is my great asset. Then I give a short synopsis of the asset, and let me just give this interesting synopsis. Some main characteristics of the assets, this again is probably a short thing. Asset type, what is this asset? Suppose it is a Docker container, for instance. Technical categories, these are the typical categories we find at IJKAI conference. In fact, they're taken from the JRC ontology. And we say that this is a planner and is also a planner for robots. Maybe there is no specific business category for this asset, but the research area of all these 5 is, of course, more related to physical AI, since it has to do with robots. Developed by, this is actually the universities that I belong to, or the institution I belong to, and Örebro University already has a profile, so it is here. Now, license, of course, if your university, your institution is not on the platform yet, you will need to create an asset for your institution. So create a profile for your institution first, so you will be able to see it here in the list. Okay. We have been very liberal in what concerns the license, so you can actually decide what is the license model for your asset. Actually, there is no forced model. Can be any one of these open source models. If you want, it can also be another model, maybe a proprietary type of license, when you explain here what type of license it is. But for this asset, suppose it is LGPL license. We can have free keyword, and I said answer set programming is 1, and then I said it is for swarm intelligence. Well, no, swarm robots. Apparently, this keyword is not there yet, so I just put it, and it will be created as a new keyword. Here is actually the website where the asset physically resides. So here I would put the URL to where my asset is hosted. Can be GitHub, can be my own site or whatever. I can put an image for my asset. Let's do that. We can actually select one of the images which is already there, or I can put an image from my on my own. And yes, I prepare this one as an image, okay, with some alternative text. Oops. Which is fields with the star, of course, are compulsory fields. Okay, so I insert this image here. Contact details, here I can put my name and email address. Detailed description, again, with lack of originality, I can put the usual lore ipsum description. And then I can put some note about GDPR requirements, if any, and about the aspect of trustworthiness of my asset. The aspect of trustworthiness, of course, is extremely important for the platform. So in fact, there is another thing we can do for trustworthiness, which is I might want to use some of the existing tools, like the European Commission Altai tool, actually, to assess the trustworthiness of an AI asset. And if I do that, I can indicate it here that this tool has been used to assess my asset as a trustworthy AI asset. I can add documents here, like I can add a user manual or a paper or something like that. And finally, this is a window where when my asset is reviewed and hopefully approved, I might find comments by the reviewers. Very often what happens is that when we approve and when we publish assets, we do a little bit of cosmetic editing just to make sure that assets all look the same, maybe moving some text from one part to the other or something like that. If we do that, we put a comment here in the review comment, so of course you will be able to discuss and complain about that if you don't like the formatting, editing that sometimes we do. That's it. Then I can save my asset. This is how it will look like. Description, here is the container. Here there is the link, the image. Contact details will only appear for users which are logged into the platform. Users that can access the platform anonymously, they will be able to see the asset, but not the contact details. And then here is all the stuff that we put in the asset. Now, if I go back to my dashboard, I see that now I have this great asset, which is currently in review. So there will be somebody actually in the reviewer team which will look at it and at some point will publish it. Now, I hope that Ioannis is actually acting as a reviewer in this moment. So maybe if I reload the page, yes, he already approved the asset and this has been published. I can, of course, go back and edit the asset at any moment if I want. That's one thing. So second thing, I said, great, now I have my asset. I also have a tutorial about this planner which I want to publish. Same procedure. I go to the contribution gateway. I go down to the education content. Okay. And here I can put an education content. The form is rather similar. Actually, there are a few differences, but similar. Again, same title, short synopsis, short summary. Education type. This can be distance learning, blended learning, MOOC, concept tutorial, which is my case here. Subject categories will be the same as before, will be about planning and will be about, will be about robotics. Level of education, well, that's a tutorial meant for researchers actually, so I would put advanced level of education, and is provided by education provider, as before was Örebro University. Target audience, this can be students, teachers, or working professionals. I guess in this case it would be a working professional, or maybe working professional and also students, why not? Again, you can have keywords as before. Now we have swarm robot is now a keyword, so we can use swarm robot, for instance, or add other keywords. And here again is a pointer to where the tutorial is actually hosted. Okay. You can put an image here. Well, there is by default this image here, but instead maybe we can remove it and put an image from the computer as we did before. Okay. With an alternative text. Okay, I guess now you got all the trick. Contact details with the same as we did before. Pace, that's probably more important for other type of courses like full-time, part-time, but for a tutorial, I would say this is probably self-paced. It is from Sweden, it is in English, does not give any credit, does not have any specific prerequisite, and once again, I may get comments by the reviewers once the asset is published. So here I can set it again. So here is how it will look like. And again, if I go to my dashboard, now I see that I also have the tutorial here, which is currently in review, and hopefully shortly it will be, let me reload the page. It's published. Wow, fast reviewer. Okay. Great, now I have my asset and my tutorial. Now the last thing I want to do, as I said, is let's actually put this together. Let's create this type of thing, create what we call a research bundle that put this asset, this tutorial, and maybe other stuff together as output of a particular small collaborative project. These research bundles are exactly meant to be that, are meant to be places where you can put different resources, different assets which are in different places of the platform, your organization, a tutorial, a data set, a case study, into one single place connected to a project under which they've been performed. So let's do it. Let's submit the new content, and this time the new content will be, I think it's down here, a research bundle. The form, again, is very similar. It can be migrate project with the usual summary and the usual short description. Let's forget the cover image now, for I think you got already all the idea. Prototype. Now, for now, these research bundles can be a micro project in Human AI. In fact, all micro projects in Human AI, as Paul said, eventually are supposed to be represented in a research bundle here on the platform. Or it can be a PhD project or a student project, and then, of course, we may add more types depending on your need, actually. Suppose this was an eco project in human AI, and suppose, as usual, that this was about planning and robotics. Here, we also indicate the technology readiness level. For this project, suppose it's just technology development at 3-5 level. We can have, again, keyword. We can have a pointer to the website when you find additional information if you want to. We can indicate who is the leading institution here, which again can be Oregon University, and so on. We can have maybe additional information, and as usual, where is it? Yes, the content details. Okay. Then we save it, and here is how the research bundle looks like. Okay. No image in this case, we didn't put one, but it will have the usual more or less information, but then it will have a number of project nodes. So here is where here is a container where we can add assets that belong to this particular research bundle. Okay. So we go back to the dashboard. We see that the research bundle is here. In fact, it has already been published. Great. Now I may want to actually start to add assets to the research bundle. I want to add the tutorial. I may want to add the migrate assets that I created before. Just as an example, if I edit again, I go to all entries here on the left menu, and here is where I actually can add a link, more asset to the bundle. I can add an existing one, or I can add a new one. So I create and add at the same time. We have it already, so I can add an existing one. Say I add the AI asset that I had. This was my great asset here, and I do it. So now the project bundle has start to be populated with assets here. One more thing I want to show. Another thing I can add actually. So let's go back to the migrate project, and I can add more stuff. And maybe I can add the tutorial I did before. But I also want to add the organizations who were involved in this project. So I can add, for instance, I could add the tutorial, but you could add actually the organization. So I add, for instance, Oregon University here. Okay. And then, I go back to edit, actually. I think we will develop a shortcut for that. I go back to edit to add, migrate project is one. I go back to edit to add another entity, and can be another organization. I said that this was a project together with the University of Bologna. I think they're called Alma Mater Studium, right? They're already there. There is a profile, so I can put that one also. So now here is the research bundle, and here are all the things which have been connected so far in the two institutions, the asset. So when I can even go one by one. There is an asset. There is no article yet. There is no educational resource yet. We'll put the tutorial later on. There are two organizations connected to that, and so on. Okay, I think you got hopefully the feeling on how you can do that. So let me go back to the slides. So, if there is any urgent question, ask it now, but otherwise we are planning to leave a few minutes at the end of the session for question, discussion, and clarifications. So if there is no pressing question, I would say I would then leave the floor to Ioannis to go to the next step. If you actually want to now contribute to change something in the structure. Yes. So, Ioannis, floor is yours.
Okay, my name is Ioannis, and I will going to talk to you about things you should know if you wanna help with the CMS development, and if you want to be a member of in our team. The things you can do in the platform and the ways you can contribute to the platform is by adding new content types, new taxonomies, changing data fields, improving layouts, and even add your own modules, like, for example, a smarter search engine or a chatbot. And the way you are going to do it is using these technologies, Drupal 9 for the actual CMS platform, a GitLab repository, and the Linux server. So you will need access to all of them, to the CMS as an admin, to the GitLab repo to just have the code and make commits, and to the Linux server, which the production platform is hosted. And of course, you have to be aligned with our workflow. The first step is to have the local installation in your setup. You have to use to see a complete guide on how to install the system locally, and then you're going to see a list of issues. You may have your own issues. You may want to do your stuff, and then you are going to design a solution. In this phase, you can always ask for feedback to the development team. Then you're going to implement your solution locally and test it in this local installation. You are going to make adjustments until your solution is ready, and then you're going to push a commit to the GitLab repository. Then you will ask for a team member to review the commit and merge it. When the team member merges the commit to the main branch, then you will be able to deploy to the server and again test it on the production server. So this is the workflow. It is really easy to follow, and we are always available as a team to help you through. And if you want indeed to join our team, you can contact Alessandro or Gabriel, but be aware that you should be in contact with DGP and receive their approval to make any changes to the platform. I will show you a quick demo on how are we going to change the layout of a specific page in a local installation. So I have my local installation ready. You can see the address is different from the actual URL of the platform. And I want to change a few things in the layout of the user profiles. I want to change the job title, the position of job title, and add a few elements more. So originally, in order to, commonly actually, in order to change the layout of content types, you are going here and choose the manage display option. But for user profiles, it's a little bit different. You have to go to configuration. Then I'm going to choose user account and manage layout. So I want to move the job title from here under the picture. So I'm going to add here the job title. And I want the label to be hidden. I will remove it from here. I'm going also to add a title here. So I want to display the title to the country field. And I'm going to add one more block telling us about when the user was registered on the platform. So I'm going to save the layout. And let's see the changes. So now the job title is under my picture. I would like to have the job title label as well being presented here, probably. I have now a label for the country, and I can see when the user was registered on the platform. So I've done my changes, and then the next step would have been to push this commit to the GitLab, and then ask for a team member to review it and merge it to the main branch. So this is the process. It's pretty easy to make changes to the layout. However, you may also need to play with the code to the backend. But that's a story we are going to tell to you if you are going to be a part of our team in the future. So that's all from me. Back to Alessandro.
Okay, so as before, if there is any direct question to Ioannis, please feel free to ask now. If not, we can actually use then the time at the end of the session to have question answering and discussion. Thanks a lot, Ioannis. It was very effective. So now we go, all this was about the Drupal part, the CMS content management system part. Now we go to the AI experiment subsystem or the platform, and Martin Peter will guide us through what you can do, how you can use it, and even how you can contribute new stuff to that. Martin, up to you.
Thank you very much, Alessandro. So let me share my screen. I hope it worked. So I would like to start with one slide about the interoperability and interconnections, because it has always been an important topic with all the follow-up projects. And what I think is very important to note is that we have at least two levels of interconnection. So on the first level, which you see in the upper half of the slide, is the platform interconnection. So here we have the AI4EU system on the left-hand side, and for example, we could exchange catalog entries with a DIH. So it's about exchanging metadata and synchronizing catalog entries. Could be done in both directions. And we also have then the interconnection to the execution systems. So you can deploy a pipeline or a model from AI for experiments, for example, to CreoDias, which will be a use case in AI for Copernicus. Those are two use cases for platform interoperability. But we have also the second level of interoperability, which is in the lower half of the slide, and it is about AI tool interconnection and interoperability, and going into the direction of cognitive architectures, which is a term that I learned from Alessandro and I like very much. So how can we build pipelines and architectures of AI models from different projects? So how do we connect our tools? How do we connect our AI tools? And this is really a different level of interoperability. So, for example, we can have tools from different domains, from different AI domains. We can have SAT solvers, we can have classifiers based on deep neural networks, we can have interaction with sensors and robotics or planning. And of course, we need to have connection to data sets, and data brokers are the reason or the mean that is used in AI for experiments for this. And here we have already the interconnection with OpenML and with the international data spaces, which is also very close to Gaia-X. So here we have really examples of how we connect different tools from all over Europe to compose pipelines of several models to achieve added value and benefits. So I believe that the next big progress in AI will be by combining different AI domains together. And this is what we want to support with the architecture of AI for experiments. And we have for this the container specification and the protobuf definitions. Here we have the interfaces. Each model has a well-known interface, how it can be connected to other models. I will show that in a moment. So that's the main message, and the most important slide that I want to show is about the two levels of interconnection on the platform level and the AI tools level. So we have already heard about it, that after the project, of course, it will continue. It's not over then, it will continue, it will be sustained. The operating is assured by AI4 Media, so there will be a task. And the source code, it will be an Eclipse open source project called Graphene. So it's called Eclipse Graphene, and it's already in the proposal stage. So you can have a look. And this is all under the Apache 2 license. So it's a permissive license. You can fork and you can even do commercial applications with it if you want. But the core will stay open source. This is assured by the Eclipse governance model. So here's a collection of links. Of course, we have tutorials, we have video, we have source code, we have tutorials. Here's the link to the Graphene proposal, and of course the container specification. Let me now go into AI for experiments. So we have the catalog here of models, which we have now nearly 260. So recently there has been the deadline of the open calls. So many of the models, the most recent uploaded models, come from the open calls. There are many very interesting models there. So it's worth to take a look. And each of the models has, of course, if you look into the details, we have a description. So in this case, we have an OpenML data broker. So it makes it possible to access a data set from OpenML, and it can then be used in a pipeline. So it has a description and a description of the data fields, of course. And it has a license profile. So each model in the catalog must have a license profile to let the user know if it's a commercial license, if it's an open source license, if it's proprietary. So this can all be supported here, and it must be part of the publication. And then, very important, in the signature tab, we have the public interface of the model as a protobuf file. So protobuf definition, it's very closely connected with the gRPC as a remote procedure call, communications channel. And this is how the models can be plugged together. So this is for OpenML, it was generated because I think we imported more than 80 OpenML data brokers. They have been selected by KnowCenter. And there can also be a documentation and model artifacts where you can download things, publisher details. So this is all part of a model as it is represented in the catalog. I also want to show briefly the International Data Spaces connector. So this is, we have also here the description, of course, and we have the signature. It's currently quite simple, but what is important is that we have, for all of those examples here for the International Data Space connector, we have source code examples in our GitHub repository. So you can really take a look at the internals. It's all in Python. It's not too complicated. We have it also for the OpenML data integration, for example, and we have it with description, so you can actually see how it is done in our tutorial section. And there we also have our container specification, which describes how the components, how the models have to be built. So it's Docker containers with a protobuf interface. So this is a very important place to look in this tutorials repository on GitHub. Now let's go into the design studio. So let's say we want to create an audio pipeline. So I will filter and I start with a segmentation. I drag it to the canvas. And then I see here the connection ports. So those are the services that are defined in the protobuf interface. And of course, I now want to connect together and create a pipeline. So I click on the port that I want to connect. So, and in the matching models tab, you can see what models can be connected to this port. So we have 3 that are possible: speaker recognition, speech to text. So maybe I want to analyze English text. So I drag it to the canvas and then I can make the connection. And I can only connect to ports that are actually, that match the interface. So in this case, this is a match. And I also want to connect in the other direction. So I will have to start with the audio file broker. I drag it to the canvas. Then I can do the connection. And maybe I want also here to continue to open a parallel path and add speaker recognition. So I also drag this to the panel, to the canvas, and make the connection. So that's the basic workflow, how to create pipelines. Now, if I want to deploy it, so AI for experiments is not an execution environment. So you have to deploy it to a user-controlled or public execution environment. And this is done via deployment. First, I need to give a name, demo 1, version 1. I save it. And then it has to be validated. So validation was successful. And after this, I can go into the deployment menu. And as you see here, there can be many different deployment options. So probably there will be a deployment option for CreoDias, for AI for Copernicus. There will, of course, be, we are still working on it for the playground. There will be a different option. And those deployment options, they are easy to add. So it's not complicated. It has been foreseen by the architecture that different deployment options are possible and are easily supported. So currently we support deploy to a local Kubernetes. So I would then export to local, download the solution package. It's called solution.zip. And then I have already extracted the contents. I want briefly to go into the contents. So you have, for example, in this solution.zip that needs to be transported to the Kubernetes cluster and then extracted. There is the pipeline description, which is used by the orchestrator to do the orchestration of the pipeline according to the definition in the design studio. So it can be used also for other purposes. It's not only for orchestration, and it can be generated in different ways. It's not only the design studio that could create the blueprint.json. Okay, we have a README file, we have the deployments. those are basically the Kubernetes artifacts that are installed into the Kubernetes system. There is also all the protobuf definitions of the services. And we have, very importantly, the Kubernetes client script that does the actually installation in the Kubernetes system and adaptation to local constraints. For example, find free ports for the different models. And then the orchestrator client is used to actually trigger the execution of the pipeline. Okay, then I want to go back to one more example. So we have here, we have the models. You can search for models. And we have the solutions. Those are the pipelines. I want to briefly show the training pipeline. So training is also possible. We have a simple approach for it. So in this example, we have the news classifier, which looks at news contents and classifies it in different topics. Sorry. And this can be used also for training here. So the news classifier exposes a training method, and it will be controlled by the news trainer, which is a combination of a data broker and controlling the training. And what is very important here is that all the nodes of the pipeline, they have access to a shared folder. So they can all read and write to this folder. For example, the training data, they reside in this shared folder. They are not transferred by gRPC. They are just referenced by file names that reference files in this shared folder. And the shared folder can actually be a whole directory tree. So there can be directories and files and a whole subtree for files. So the exchange of data can be done via this shared folder. And this is also how we connect the Tensor board. As you know, Tensor board is actually interpreting log files in a specific format that is written by the model. And the log file is then available also in the shared folder, and Tensor board is then available to read in and evaluate in a visual way a diagnostic information about the model and the training, how it went. Okay, that was the end of my presentation. So I give back the floor, I think, to Peter. Thank you very much.
Thank you, Martin. I will first talk about the onboarding of the model. Martin has showed what you can do with the models. For onboarding the model, you need a protobuf file and a URI to a Docker registry. It can be Docker Hub, it can be another Docker registry. And I have already written here, the container should respect the container specification, otherwise it doesn't make much sense. If you just want to play around with Akku Compose, with this design studio, to assemble components, you only need a protobuf file. Everything else here, you can fill in whatever you want. I will show now. So, I'm here in the AI4EU experiments platform. I go to onboarding model. I will onboard another version of the Sudoku GUI. And let's use let's use Docker Hub. So there is my user on Docker Hub is Peter Schüller, and I have a project that is called AI4EU. And there I can say the GUI graphical user interface with version 1.4, the tag. And now the most important thing, as I said before, uploading the protobuf file. And we need to click upload. Now we can click onboard, and in a few seconds this all should be green. Yes, it is all green. Now we cannot use the model yet because the Acumos core doesn't know yet what is the category of the model. We have extended Acumos a lot to make it more generic, to work on generic artificial intelligence solutions, not only machine learning. And for that, we created this container specification. And this container specification more or less means that all assets have very similar categories, but we still need to choose a category, for example, to know if something is a data broker or not. So I will here say it is a data source, and I will select scikit-learn as the toolkit type. Now it is saved, and now I'm ready to play around with it in the design studio. If you want to publish your asset publicly, you also need to fill in all the documentation, license, and everything. If you just want the private version of your asset, this is enough, what I did. Data sources, my other Sudoku GUI is here. I can pull it here. And as Martin showed before, I can click on the node and I see, okay, we have 2 Sudoku design evaluators that are already ready to be connected to that. I can also edit an existing solution. So I will discard this solution and open the Sudoku tutorial. And let's say, okay, I want to replace this user interface with my new user interface. So I click delete on the publicly available solution. And I just plug my new component here. And I see the port is plus, input plus, and this is output plus. I can connect them. And then the result, the brown triangle is here. And suddenly I have edited the existing solution with my new user interface. I will now, just a second, yes. I will go back to the presentation. Yes. Now I will show how to, well, actually Martin showed this already, how to get the solution zip. I wanted to mention for this onboarding process, configuration, and deployment of assets and solutions, there is also a YouTube video, a YouTube tutorial that is much slower than what I will show now. So for the demonstration, I will load again the Sudoku tutorial and will deploy it. Download the solution package. Here you see the zip file. And now I will go to the shell. I hope you can see my shell. But I assume yes. You might have noticed I'm on Windows, and I'm in Windows subsystem for Linux 2 now, where I have also installed Docker and Minikube. I'm getting the solution zip Martin has shown before, and those are the same contents as before. And I will check if my Minikube is running. Yes, my Minikube is running. What is Minikube? Minikube allows me to have a Kubernetes environment on this local computer. And this computer doesn't need to be a high-end computer so that you can do this. It really depends what you want to run on this Minikube, how much memory and CPU power you will need. Minikube is not a huge load to the computer. So Minikube is running. I will check which namespaces I have in the Kubernetes. I will create the namespace Sudoku. And now I can have a new empty namespace. And in that namespace, I will run the solution zip. So I run with Python the Kubernetes client script, namespace Sudoku. Now this does a few things and tells me at the end, okay, that's the IP address of the node, that's the orchestrator port. The orchestrator is the piece of software that connects all the components. And it's also a container. It's automatically added. I now copy this please run, because I will need it later. But before I run the orchestrator client, I will check if all my containers are actually running. So I check in the namespace Sudoku get pod. There are 4 pods, the ASP solver, the orchestrator, the design evaluator, and the tutorial GUI. They are all running for 30 seconds. That's how long I have been talking since I ran the script above. So that is fine. Now I can run the orchestrator client. And this orchestrator client starts, submits the content of the solution file, solution zip that we had, to the orchestrator container so that the container knows how to connect all the components. And now what happens? Now we would want to have a user interface, right? We have a user interface. I will open a second console. I will check what are the services that we have in our Kubernetes application. Now, because I'm on Windows with Windows Subsystem for Linux, I need to tell Minikube, give me access to a certain service. So again, in the namespace Sudoku, I ask for the service with the URL, and I need the web UI from the graphical user interface. You notice here that every component is there as its own service and as a web user interface. This is in the container specification. The container specification specifies that every component can come with a user interface, a web user interface. And the deployment gives access to this via such services. So in theory, every one of these components could have a web interface. At the moment, it is only the designated user interface for this tutorial. So I now start this tunnel, and this tunnel tells me, this needs to run. If you run everything on Linux, you don't need this, because you can access directly via the node. If you run everything on Windows, you also don't need this. If you run everything in another Kubernetes environment, things might be different. But with Minikube, it works like this. There is the URI, and I enter the URI, and I can see my my Sudoku grid user interface. Now I can say I want to have a 2 here, and I get a partial solution. This is already a computation of the pipeline. Now, okay, this should not be a 1. This is a 5, partial solution. Now I want another 5 here. Oh, the system tells me I have a conflict, and this red 5 is one candidate to change to get a solution again. But I'm clever, I know that this 5 can also be changed. So I make it into a 3 and I get a partial solution again. So you all know how Sudoku works. And that's why I will stop here, but I will show I still have these windows open. And in these windows, I can show that each change I do here. So now I clicked wrong, of course. Now I clicked, and here the orchestrator client showed us some events that happened. It showed us that between this and this component created a message package. This component, this queue transmitted it. The queues are the lines between the components, and this component got it into its input, and so on. So if you have any trouble looking at this log of the orchestrator client, these events can be very helpful. Now I look at my cheat sheet. What else did I want to tell? Yes. I will go back to the presentation. I have also summarized this on the slide. And finally, I want to talk about streaming. As I said before, we have extended Acumos so that we can do more than just machine learning with it. In particular, we added the possibility to use the streaming keyword in protobuf. This means that an RPC call, a service that is created by a container, can consume streams of messages, not only single messages, and can produce streams of messages, or both. And also you can freely connect the streaming to the non-streaming ports. What are the benefits of this? For example, you can have components that have other components as subcomponents. This is, for example, useful in the Sudoku example, where the answer set solver that actually does the computational work is a subcomponent of the component that knows that is between the user interface and the answer set solver, the design evaluator. And the answer set solver does not need to know that it's a subcomponent. Only the caller needs to know this, and the caller streams out the requests and streams in the responses from the other components. So we have a cycle here. And this caller, again, to the outside has an interface where you don't need to know that it has a subcomponent. Because of streaming, you don't need to know this. And another benefit, you can have control loops. We can have solutions that are deployed from Acumos that have loops, control loops, and various control loops with different frequencies. Because of streaming, the frequency of the messages is not determined. You don't need to have one output message for one input message. You can have a variation. In this example, this is a hypothetical. You have a user interface that streams commands to high-level commands to a planner. The planner gets input from a perception module. The planner gives low-level command information to a controller. The controller also uses perception as input and streams out the actuation signals to the simulator. And the simulator streams out the world state to perception at the user interface. So this is another example of something we added to Acumos to make a more general AI platform for everyone. And that is already the end of my talk, and I give back to Alessandro now.
Okay, thanks a lot, Peter. Thanks, Martin. This was very, very informative, I hope. So I think we've seen all the different ways in which you can use and especially contribute stuff to the platform, from the simplest case when you simply put your organization profile or your libraries or on the platform, to the most complex case when you create AI experiment or you even help in the development of the platform. I think there is one thing that Peter says that I also want to emphasize even more, which is in this AI for experiment thing, I think it has a very unique feature. Peter shows the technology behind it, but apart from the technology behind it or the using streams and so on, I think what is a great, in my opinion, the great innovation of this AI experiment is that now we have a way to create modular systems that you can compose in different ways, which is really general for any type of AI component. I mean, Acumos is nice, but Acumos was really designed for machine learning component, reactive components connected in a pipeline. Now, these changes allow us to use a generic AI component, maybe machine learning component, maybe knowledge-based components like Peter showed, a planner or an ASP solver, possibly hybrid, possibly some machine learning component and some knowledge-based component, and to put them together not just in a pipeline, but in any sort of topology, including loops, as Peter showed, and so on. This means that now we have, well, the beginning of course, a lot needs to be improved, but we have the starting of a general tool to compose modular reusable components into complex AI system. We didn't have it until now, and my expectation is that this will help the field of AI tremendously, the same way as the introduction of ROS, for instance, helped the field of robotics to make a huge jump and a huge leap forward. Having said that, I guess we'll open the floor to any sort of questions from the audience or additional comment from the speakers.
Yes, I have one more comment. We showed a lot pipelines, but it's also possible to deploy a single model. So it also works with a single model. If you want to just try out one model, it's also possible to deploy it. It will just not contain the orchestrator then. Okay.
And I wanted to add, it is good that you mentioned ROS, because with streaming, we can also interface with ROS as a solution. So this is not meant as a replacement for ROS. This can sit next to ROS, and you can communicate with a ROS solution with an ACOMOS, with an AI4EU experiment solution.
Any questions from the floor? Can probably either.
So let me ask the people here if you have some questions about. So first of all, let me thank you guys for the super comprehensive description of the platform, and also, I mean, it was really interesting. So, I mean, yeah, we have a question. Wait a second, that I will bring the microphone.
Hello, this is Fabrizio Riguzzi. My question is, so the containers should be hosted by the developer website, right? So the platform does not store the container.
That's correct, yes. So data sets and containers, they are only referenced. That's correct.
Okay, thanks.
Other question from the audience?
I may also add, thanks Fabrizio for the question. I may also add something about the rationale for that, because initially we were sort of hesitating between should we really host the assets, dataset, containers, library or not. Now the decision is not to host them, but just to be, yes, an index to things which are physically hosted somewhere else, so it's a distributed solution. And one of the reasons is actually ease of maintainability. The fact that, I mean, if we start having, and we had at some point, I don't know, libraries which are replicated both on the AI4EU platform and on GitHub, then it would be a mess for the developer to actually maintain multiple copies. So we thought it's better to actually only keep pointers in the AI4EU platform.
And I may add to the point of data sets. So you need to bring the pipeline close to the data set. So if you have the data set stored on AI4EU experiments, then you would have to copy it again to the execution environment. And by just accessing it via a data broker, it is much more efficient for all participants.
I guess if not, there is any way, you're very welcome to contact any one of us. So the last slide, you will get the slides, of course, are the contact points. But apart from the contact point, apart from the people who presented today, which I really thank for the great work, but let me also thank what are, as I said, it is a distributed development. So a lot of people contributed to this development, both for the CMS part and for the experiment part. I think the one who contributed most are in the list here on the slide, but it's not even all of them. Other people contributed in several ways. And we really hope that, I mean, by leaving the platform open as it is, by having set up this technical board that will coordinate any further development on the platform, we really hope that we created an infrastructure that will be used now by the community, by everybody, will be carried on, will be a seed to become actually your platform that we all contribute to update and develop the way we need, actually.
Yeah, I fully agree. So let me also add my thanks to, the speakers, but also, yeah, of course, to the whole team for the distributed development. So if there are no other questions, I really thank you guys. Thank you, Alessandro, for moderating this and for the whole thing. Thank you to all the speakers. And so we now make a break. We have the lunch break. We'll be back at 2 with the panel on education and upskilling.